Hi, Algebra 2. Let's talk about Chapter 1, Section 3, Solving Linear Equations. Hopefully we know by now equations mean we have an expression equaling, must have that equal sign, another expression. And if we can say that this is a true statement, that's when we can solve for a missing value, a variable. Our goal today is to solve equations, and a key thing to keep in mind, you can perform any operation you want on an equation as long as you do it to both sides identically. Has to be the same on both sides. Keep that seesaw in mind. Whatever you do to the left, you must do to the right. They must balance each other out. So here we go, some examples. First one, I would like us to solve with the variable and check our work. Our first equation is this. Let's make that negative 18. We have 2/3 y equals negative 18. So I see that I am multiplying here. And by seeing it, I mean that I don't actually see any operation. Multiplication is the only operation that we don't need to see. But I know that it is right there, multiplication. So I am going to, because I have a fraction 2/3 here, I am going to multiply by the reciprocal here of 3/2. Again, I must do it to both sides to keep things in balance. Multiplying by the reciprocal gives me 3/2 multiplied by 2/3, which is just 1. That's the beauty of multiplying by the reciprocal. 1y equals, now this is negative 18 over 1 multiplied by 3 over 2. I'm going to go do some side work over here for a second. I see that this 18 and the 2 can cross cancel a little bit. If I divide them both by the factor of 2, I'm left with negative 9 and 1, which leaves me with negative 27 over 1, which is just negative 27. So I know that 1y is actually just y, so I have my final answer of y equaling negative 27. The beautiful thing about solving equations is that you can always check your answer by plugging what you think you just got back into the original equation. So I had 2/3 times y equaled negative 18, and I am currently thinking that this is negative 27. Again, this is really over 1. That helps me multiply by my fraction. Again, I see that the 27 and the 3 can cross cancel. If I divide them by the factor of 3, I'm left with 1. I'm left with negative 9. 2 times negative 9, I get negative 18 over 1, which does indeed get me negative 18. So I am correct with this answer there. So that's your first example. Let's try another. How about, again, we're going to solve for the variable, check your answer. How about 5 multiplied by x plus 3 plus 2 multiplied by 1 minus x equaling 14. I would like us to solve for x. So first thing we're going to do is simplify. Before we get into the solving number crunching here, I want to simplify first, and I'm going to use my distributive property to do that. I see my 5 can be multiplied here. I get a 5x plus a 15. I see my 2 can be multiplied here. Watch those negatives. You end up with a negative 2x there. We are equaling 14. I see some like terms here and here, and then also my whole numbers, 15 and 2. In the end, I get 3x plus 17 equals 14. Now I'm at a point that I can solve this pretty simply. It's going to be a two-step equation for us. You always want to start with the operations and the numbers that are farthest away from your variable. My variable is tucked right here, being multiplied by 3. The plus 17 is farther away than the multiplying by 3. So I am going to subtract that 17 off to the other side. I'm left with 3x equaling negative 3. One operation left, I'm going to divide by that 3, and I am left with my final answer of x equaling negative 1. At least I think that's what it is right now. I'm going to check my work just to be sure, so I'm going to plug it back into the original equation. I had 5 times x plus 3 plus 2 times 1 minus x, and it should equal 14 in the end. But I need to plug in this negative 1. So over here, I'm going to have 5 times 2 plus 2 times, remember this is subtracting a negative is the same as adding a positive, so I have a 2 right there. I would like this whole thing to equal 14. Order of operations, I'm going to multiply everything before I add everything, and lo and behold, I get what I want. Therefore, my answer of x equaling -1 is correct, and life is good. So these are just straight solving equations. Let's talk about a formula. We talked about formulas already. We can use formulas to, there we go, you can see it now. We can use formulas to understand the relationships between different quantities. In this particular case, I want to talk about the area of a trapezoid. Remembering geometry class, a trapezoid is when we have a shape that has two sides that are parallel and two sides that are very much not parallel. So this guy is parallel to this guy, but these guys are clearly not parallel to each other or anything like that. Couple important parts here. The area consists of the height. The height we get from going directly from the top to the bottom, straight down. That is my height. And I need my two bases, base 1 and base 2. This little guy here, the base 2, this is called a subscript. And it's just a way for us to keep track of the variables, especially when we want to use the same letter in two different instances, but we know they mean different things. So if the formula for the area of a trapezoid is area is equal to 1/2 h times the quantity b1 plus b2, so the half of the height multiplied by the sum of the bases, where h represents the height, b1 and b2 represent the measures of the bases, solve the formula for b2. So I'm just going to rewrite this formula so I have it. And now this one, we're not really going to get a definitive number answer. They just want us to rearrange the formula, and this is helpful a lot of times in sciences, in higher level math classes, where maybe I need to solve for one of these when maybe I know the area, but I don't know what the second base is. So let's solve for this. My goal is to solve for B2. So I'm going to color that just so we know which one we're solving for. Again, we want to start the farthest away from B2. I see that B1 is right stuck against it, so I'm going to save that one for later. But I'm going to deal with this 1/2 and this h first. First thing I'm going to do is multiply this whole equation by 2 on both sides. Why that helps me, this 2 and this 1/2 are going to completely cancel each other out. They are multiplicative inverses. Over here, I'm left with 2a. Now I have an h and I have a b1 plus a b2. Now I'm going to go for my h. I see that I divide h on both sides because I'm multiplying there, so the opposite of multiplication is division. So I'm going to divide over there. So I have 2a over h equaling b1 plus b2. I don't need the parentheses anymore because everything has canceled away except the b1 plus the b2. I'm solving for b2. I have one step left. I need to subtract b1. Notice subtraction is not commutative. I need to put it in the right spot. Since I subtracted off the right, I need to subtract off the right on both sides of the equation. So I have in the end the fraction 2a divided by h subtracting b1, and that is how I get b2. So that is my rearranged formula to solve for b2. There we go. So a little bit of practice with solving linear equations, and we will practice some more in class.